Hello everyone, welcome to my 8th video. Today we will be looking at how data is arranged and manipulated by the computer, and more importantly, why it is arranged the way it is. Let's get into the video. As you might have heard, computers store data in something which is called the binary system. Binary means something that involves two things only, which in this case is 0 and 1. This is a number system. Like we all know, the most common number system that we use is base 10. Base 10 involves the integers 0 through 9. This has been used for a long time, and it actually seems logical because many centuries ago, our ancestors used their fingers to count things. If we only had 4 fingers on each hand, our number system could have been in base 8. A question worth asking is, why would computers store memory in binary? Computers use binary numbers because they have circuits which are either on or off, which only gives them 2 states to operate on to make calculations and run processes. One state is when a circuit is provided with electricity, and the other is when a circuit is not provided a source of electricity. These states are represented with zeros and ones. 1 symbolizes on, and 0 symbolizes off. But what's the point of binary? It seems like it's just a shorter number system which requires a lot more work just to represent shorter items that we are familiar with, like the word dog or the number 965,000. So the whole point of binary is that it is efficient for the computer. We are not doing the calculations. The computer only has to check between 2 states. It's not efficient for us, which is why we humans do not read in binary. We learn about binary simply because the computer reads like that. Now let's look at how we represent numbers with their given bases. So base 10, which is also known as the decimal system, uses powers of 10 to represent numbers. So as you can see on this piece of paper, 10 to the 0th power represents the ones place, 10 to the 1st power represents the tens place. So the power of 10, you can change that to represent any given number. Likewise, in base 2, which is binary, we have powers of 2. So 2 to the 0th power represents the ones place, 2 to the 1st represents the twos place, and then the 2 to the 2nd power represents the fours place. So this can keep on going on. But if we want to convert a number from base 10 to binary, we have to follow a set of rules, as we have defined with the power system. So if we want to convert 12 base 10 to base 2, we have to see what powers of 2 do we have that add up to 12. So if we look at the side of the paper, we can use 2 to the 3rd power, which is equal to 8, and 2 to the 2nd power, which is equal to 4, to get 12. So the answer in binary is 1100, and now let's analyze this. So when we start with the ones place, which is 2 to the 0th power, how many of those do we use? 0, so we only put 0. 2 to the 1st power, we don't use any of those. And then also 2 to the 2nd power is one that we use, because we use 4 in our sum of 4 plus 8. Likewise, 2 to the 3rd power is also used. So this is why the binary representation of 12 base 10 is 1100. Also, if you want to convert 13 base 10 to base 2, we will just need a 2 to the 0th power added onto our 2 to the 3rd and 2 to the 2nd. So 8 plus 4 plus 1 is equal to 13. And please leave any comments regarding any questions you have about this, because this can be a pretty tricky topic. Now that we get a feel for how binary works, we can learn some new information. Every non-negative integer can be represented with binary, and each digit in a binary number is known as a bit. 4 bits are called a nibble, 8 bits are called a byte, and so on, as you can see in this list. Thank you for watching this video, and I hope to make a part 2 on more analysis and binary representation.